Now we're going to talk about quadratic equations, and we're going to solve some problems that use quadratics. So objectives are understand the basic concepts about quadratic equations, use factoring, the square root property, completing the square, and the quadratic formula to solve quadratic equations. So remember, a quadratic function is written as f of x is equal to ax squared plus bx plus c. And again, because of that squared, we know it's a parabola. And this is the general or standard form. If we replace f of x, so another name for f of x is the y value, with 0, we now have a quadratic equation in one variable written in the form ax squared plus bx plus c. And instead of f of x, it's now going to be equal to 0. We must understand that when we set the equation equal to 0, this means that graphically we are looking for x-intercepts. So when we set the equation equal to 0, we're looking for x-intercepts. As such, there are 3 possible outcomes when dealing with quadratics. So we can have 0 solutions or no solutions. So this function, this graph right here, is y equal to x squared plus 1. And if we set it equal to 0, we can see that it does not cross the x-axis. It doesn't cross it. So as such, we have no x-intercepts. Another possibility is that we have 2 solutions. And here is this graph. So this graph, if you were to put it in a graphing utility, is y equal to x squared minus x minus 2. And if we set the equation equal to 0, then we see that we have 2 x-intercepts at negative 1, 0, and at 2, 0. And the other possibility is that you just have one solution. And here, for this graph, if you were to put in your graphing utility y is equal to negative x squared plus 4x minus 4, you would get this graph in blue. And if you set it equal to 0, then you would just get this one x-intercept right here, which is 2, 0. When it doesn't have x-intercepts, we're going to say that graphically it doesn't have any, but later on we're going to say that it has 2 imaginary solutions. Just FYI. So quadratic equations can be solved symbolically by a variety of methods. So factoring, it's the quickest, but unfortunately it only sometimes works. Completing the square, this one always works, but it can get messy. The square root property only sometimes works, and the quadratic formula, it always works, but we've got to remember the formula. Sorry for the background noise. They can also be solved graphically and numerically. However, the exact solution can always be obtained symbolically. So let's do one of these methods. So using the square root property. You can only use the square root property when you have this type of quadratic equation and k is not negative. So this is it. You have an x, it's being squared and it's equal to k. And the solutions are going to be x is equal to positive and negative, the square root of k. So let's do this example. So we have x squared is equal to 25. And to get rid of a squared, we need to remember that we take the square root. And what you do to one side, you do to the other. And since the squared and the square root cancel each other out, they're inverses of each other, then we're just going to be left with x. And we got to remember that when we take the square root, it's going to be positive and negative 5. And this is our answer here. Another thing that I'd like for you to learn, if we haven't noticed, so I already graphed a bunch of the equations that we need for this recording. But anytime you have sorry. Anytime you have an equation, that means an equal to sign and you have something on the left and something on the right, you can graph it. So on the left side, I already put x squared, and there's the graph of x squared. Let me put this a little bit higher. And then on the right hand side, if you're going to be using Desmos, you need to put y equal to 25. And so there it is in blue. So x squared is in red, and y equal to 25, which is the 25 on the right hand side of the equation, is the blue line, horizontal line. And if I click here on these points of intersection where they both cross each other, you notice that my x values are the -5 and the 5 that I got algebraically. So this next one, 9x squared minus 11. So here on this one, let me go over here. So I already graphed, let me get rid of these here. 9x squared minus 11. So let me turn these off. And let me zoom in on this so that you can see it. So I have 9x squared minus 11. You're like, oh, God just showed us how to do this on the calculator. So let's go ahead and just use the calculator. So I have 9x squared minus 11, and here's the graph for it. Here it is. And then for the y equal to 0, for the 0 part, again, I'm going to put y equal to 0. And if I hit these, if I click where the point of intersection is, I get negative 1.106 and positive 1.106. Those answers, unfortunately, are approximations. So if you're asked for the exact answer and you put these two x values, it's going to be wrong. So now let's do it algebraically. Here we go. Right here. All right, so I have 9x squared minus 11 equal to 0. So I want the x by itself. The first thing that's got to go is that minus 11. So to get rid of a minus 11, I'm going to add 11. And I add 11 to both sides to keep the equation in balance and equal. So 0 plus 11 is 11. The negative 11 and the plus 11 technically simplify to 0. And on the left-hand side, I'm left with 9x squared. So the x is still not by itself. I'm multiplying with a 9, so to get rid of a 9, I'm going to divide both sides, again, to keep it in balance. 9 divided by 9 on a good day simplifies to 1, times x squared gives me x squared. And I'm going to have it equal to 11/9. My x is still not by itself, it's being squared, so to get rid of the squared or the power of 2, I need to take the square root. And on the left hand side, I'm left with x is equal to, and again, I can't forget, it's going to be positive and negative, the square root of 11/9. Now, I can simplify this into the square root of 11 over the square root of 9. And the square root of 9 is a beautiful 3. So it's going to be x is equal to plus or minus square root of 11 over 3. And if you do square root of 11 over 3 on your calculator and square root of negative square root of 11 over 3, you're going to get those decimal approximations that we saw on the calculator. All right, next one. So it says solve 2x squared plus 2x minus 11 is equal to 1. So again, here graphically, you must understand that this equation is asking for the quadratic function f of x equal to 2x squared plus 2x minus 11. When is the f of x, which is the y value, equal to, so hang tight so you can see where I'm highlighting. So this is the black part that I highlighted, and then is equal to, and then we have 1. All right, so let's go ahead and use our graphing utility here. Let me zoom this in here. So let me turn these off. So I already typed it in. So there's 2x squared plus 2x minus 11 in blue. and y equal to 1, I'm going to put it here. And so I'm going to do a little sketch on my notes here. So I'm going to try to mimic the colors that we have so we can see which one. So here this is the 2x squared plus 2x minus 11. And the equal to 1, we had it in green. Oh, come on. So it's not to scale. And let's see if we get some values here. So for this point, it is going to be -3, 1. And for this point, it's going to be 2, 1. And if I'm going to do an x and an f of x chart, I can actually just write these in here. So when is the f of x, the value equal to 1? So our answer is going to be x is equal to -3 and 2. So when our x values are -3 and 2, we're going to get y values of 1. All right, let me zoom out here. Now, let's set the equation equal to 0. So graphically, all right, so let's set the equation first. We're going to rewrite the equation. So 2x squared plus 2x minus 11, I'll do this first, is equal to 1. So if I'm going to want to set it equal to 0, I can't just erase the 1 on the right hand side. I need to get rid of it. So to get rid of it, I'm going to subtract 1 from both sides. And I'm going to align it already with what I want, with what it's going to combine with. And so I'm going to be left with 2x squared plus 2x minus 11 minus 1 is minus 12 is equal to, and then 1 minus 1 simplifies to 0. So I'm left with 0. So I'm going to get 2x squared plus 2x minus 12 is equal to 0. Now, graphically, you must understand that this equation is asking. And so here we go. For the quadratic equation, two x squared plus 2x minus 12, when is the y value equal to 0? So here it's different from the example that we just did. So this part right here is this right here, and then we want is equal, and then we want is equal to, and then we have 0, but not 1. But if you notice, it's the same equation, so we should get the same answers. We're still going to get -3 and 2. So let's confirm that. All right, so now I'm going to go zoom this here. I'm going to turn these two off. And so I have the 2x squared plus 2x minus 12. And then I have the y equal to 0. And I'm going to put those, highlight the points. And if you notice, I get again -3 and 2 for my answers. So let me do a little sketch here. I don't think I'm going to get the purple. Oh, I am. Nice. So for this one, it looks something like this. Not to scale. I'm not going to use, I'm going to use a different color for the x-axis. And then this one right here. But the important part is to get these. This is -3, 0. And this one is 2, 0. So for x, and this is my y's, or my f of x, I get -3, 0, and 2, 0. So let's go back and read the question. It says, for the quadratic equation 2x squared plus 2x minus 12, when is the y value equal to 0? So here my y value is equal to 0. And when is that going to happen? Well, my answer is going to be when x is equal to -3 and when x is equal to 2. Now, so we solved this equation. Which equation? We solved this two different ways graphically. The original equation itself, which we did right here, and by setting the equation equal to 0, which means specifically looking for the x-intercepts. In this one right here, we were just finding where they intersect. And in this one right here, we were finding specifically the x-intercepts of the graph. Now we're going to do it algebraically. So we already know our answers. It's going to be -3 and 2 all the way through. But here, this is something new for this class. So make sure we put a note of it, know where to reference it. So steps to, technically here, to solve a quadratic equation, excuse me, by completing the square. So if you go back to the other notes, well, let me read these. Number 1 says, isolate x squared and x's on the left side of the equation. If I go back to the notes on right here, these were the steps to change from general form to vertex form. And one of the steps was to isolate the x squared and the x's on the right side of the equation. So be careful to know the difference. So these steps we're going to use when we want to do from general form to vertex form. These steps we're going to do when we have an equation and we just want to solve it by completing the square. So that's why the step here it says differently. So number 1 says isolate x squareds and x's on the left side of the equation. Make sure that a in ax squared is equal to 1. And that 3 and 4 are the same steps. And number 5 says use the square root property to remove the power of 2 and eventually solve for x. So before we do these, let's we're gonna follow these steps right here. But before, let's do factoring here. So we're gonna solve the problem that we just did 3 different ways algebraically: by factoring, by completing the square, and the quadratic formula. So let's do factoring. And I put here, don't forget to set the equation equal to 0. So the original equation was 2x squared plus 2x minus 11 is equal to 1. So I have to set it equal to 0. So I'm going to subtract 1 from both sides. And I'm going to get 2x squared plus 2x minus 12 is equal to 0. So the key thing here is to be in factoring mode. So if I look, 2x squared plus the 2x minus the 12, they're all even. So to make my life easier, I'm going to factor out a 2 first. Now, sometimes this isn't possible, and sometimes you're not going to see it. If you don't, you're just going to have to do a little bit thinking when you're trying to factor. But if you do see that all of those terms are factorable by a number, go ahead and factor it out to make your life easier. So this is going to be 2 parentheses, and then I'm going to have here equal to 0. So the question is 2 times what gives me 2x squared? Well, on a good day, it's going to be x squared. And then 2 times what do I put here is going to give me a plus 2x. So it's going to be plus an x. And then 2 times what gives me a minus 12. Well, on a good day, that's going to be a minus 6. So right now, this is what I have. I have 2 parentheses x squared plus x minus 6 is equal to 0. Now, I can divide by 2 to get rid of it. And I'm going to, again, 2 divided by 2 simplifies to 1. And 1 times x squared plus x minus 6 is just x squared plus x minus 6. And then 0 divided by 2 is 0. So I'm left with x squared plus x minus 6. Thank goodness that here I have an understood one. It makes my life easier when trying to factor. So I'm thinking here, so how do I get an x squared? Well, that's nice. It's x times x. And I'm thinking of what 2 numbers multiply to give me a minus 6. And when I add them, give me an understood positive 1. And on a good day, it's going to be a plus 3 and a minus 2. If you don't believe me, FOIL it out, and you're going to get this equation right here. The next thing that you need to do is set each factor equal to 0. So set each factor equal to 0. So here I go. So what is a factor? It's anything that has a variable and it has, so it's going to be x plus 3 is equal to 0. And the other one is x minus 2 equal to 0. And then we solve for x. So I'm going to add 3 to subtract 3 on both sides for this equation. And I'm going to be left with x is equal to negative 3. And then I'm going to add 2 to this equation to both sides. And I'm going to get x is equal to 2. And yes, definitely deja vu. We are getting negative 3 and 2 as our answers over and over. Okay, the next process. So the unfortunate thing with factoring is that it sometimes doesn't work. So I obviously picked a problem that it does work so that we can see that all of these different processes that we're learning possibly work. But there are going to be some equations that they just do not work. But completing the square works all the time. But it does get messy. It does. And then we have steps here that we need to reference if we don't want to memorize them. Excuse me. Okay. So the original problem was 2x squared plus 2x minus 11 is equal to 1. And so here I'm going to put step 1. Excuse me. So step 1 says isolate the x squared and the x's on the left side of the equation. Okay, so if that's the case, then I need to move the minus 11 to the right-hand side. So I'm going to add 11 to both sides. And keep it in balance still. So I'm going to be left with 2x squared plus 2x. So these are going to simplify to 0. And 1 plus 11 gives me a 12. So I'm going to take this really slow. Please pause the video if you need to digest here what's going on. Okay, so that's step 1. Step 2 says, make sure that the a in the ax squared is equal to 1. Okay, so right now, my a is equal to 2. And which 2 am I talking about? It's this 2. So unfortunately, I'm sad because I got some work to do. So to get rid of the 2, since it's multiplying, we need to divide. Okay, so here I go. So I have 2x squared plus 2x is equal to 12. So I need to divide by 2, so I'm going to divide everything by 2. So we need to realize that this is technically 2x squared over 2 plus 2x over 2 is equal to 12 over 2. And here we're going to be left with these simplify to 1. So do these. And here I'm going to be left with x squared plus an x is equal to 6. Sorry for the background noise. Okay, so now I have an understood 1 here. Now I have an understood 1. So now I'm happy. I am happy. All right, so we're done with step 2. And then here's step 3. Step 3 says take half of e, square your answer, and add the final result to both sides of the equation. Okay, so if we remember from our previous notes, our e, I'm going to write it down here, our e is equal to 1. Now, which one am I talking about? Maybe I shouldn't have used this color here. I'm not. I'm going to change it. Okay. So I'm going to say, my e is equal to 1. Now, which one am I talking about? Remember that the e is the number in front of not the x squared, but just the x. So here I have an understood 1. Okay, so my e is equal to 1. Then what do I need to do? I need to take half of e. So half of e is the same thing as e divided by 2. So my e is 1. So I'm going to put 1. Now I'm going to divide it by 2. So it's a half. Okay, well, it's a half. Some of you might want to put 0.5. I'm not going to put 0.5. And so I'm going to come over here since I'm running out of space. Okay, so take half of e, and then I'm going to square my answer. Okay, so square your answer. Okay, so square your answer means 1/2, and I'm going to square it, which a half times a half is technically a 4th. Or you can say 1 squared is 1 divided by 2 squared is 4. Okay, so I squared my answer, and then I'm going to add the final result to both sides of the equation. Okay. All right. Let me put here, add result to both sides of equation. So what is that going to look like? So my equation right now looks like x squared plus an x, I'm going to leave a space, and I have equal to 6. And I'm going to add 1/4 to both sides. All right, step 4. So step 4 says to rewrite your equation as a perfect square. If you did this right here is a perfect square. And you need to go back to your previous notes. But technically, it's going to be rewritten as a parenthesis with a squared, and you're going to put an x here, and technically in this spot right here you're going to put the half of e. So the half of e was this right here, and I'm going to put it here, and since it's positive I'm going to write plus 1/2, and then it's going to be equal to, now 6 1/4. So if you remember your fraction days in middle school, fifth or maybe even fifth grade, I can rewrite, I'll put it over here. 6 and a fourth, the shortcut was to multiply the 6 times 4, which is 24, and add 1 to give me 25 fourths. So that goes here, 25 fourths. Sorry for the background noise. All right, so here on this one, now I'm going to do step 5. So step 5 means to use the square root property. So this x plus 1/2 quantity squared is equal to 25 fourths. Now it's saying that I can use the square root property. Yes, I can, because I have just a squared on the left hand side. So I'm going to be able to take the square root of both sides. And so on the left hand side, I'm going to be left with x plus 1/2 is equal to, so the square root of 25 over 4, you need to remember is going to be positive and negative. And the square root of 25 is a beautiful 5. And the square root of 4 is a beautiful 2. So I have x plus 1/2 is equal to plus or minus 5 halves. Well, the next thing that I'm going to do is I'm going to subtract a half from both sides. So I'm going to subtract 1/2. And I'm going to subtract 1/2. Oh, this is getting ugly. I apologize. So you need to realize here that there's two answers. It's going to be negative a half plus 5 halves. And the other one is going to be negative a half minus 5 halves. If you do this in your calculator, negative a half plus 5 halves, plus 5 halves is 4 halves. And 4 halves divided by 2 is the 2. So there's one of our answers that we've been getting. Negative a half minus 5 halves is negative 6 halves. And negative 6 halves is the negative 3. So there's completing the square. Painful, but always works. Now the last one. So this is a new concept. Yes, for this class, some of you probably this is the first time we've seen it. So please study it. It's definitely going to be assessed later on. Okay, so the last one, quadratic formula. You've seen this before. You just need to make sure that your quadratic equation is equal to 0. That's very important. You need to know what your A is, what your B is, and what your C is. And then you need to memorize this formula. So x is equal to negative b plus or minus square root of b squared minus 4ac all divided by 2a. So pretending that we haven't done the other forms, we get 2x squared plus 2x minus 11 is equal to 1. It's not equal to 0, so we need to subtract 1 from both sides. And we get 2x squared plus 2x minus 12 is equal to 0. We could factor out here and make our life easier, but I'm going to pretend that, we're not going to factor. So we're just going to be dealing with bigger numbers, but that's okay. So using this equation right here, we get that a is equal to 2. And that 2 that I got, this 2 is this 2. And then my b is 2. And that's this 2 with the sign. And then my c is negative 12. And that's this negative 12 is that minus 12 right there with the sign. And so all I need to do is substitute stuff in and then use order of operations or my calculator to get the exact answer. So I'm going to have x is equal to, so this is what Murga does. Wherever she sees a variable, she's going to put a parentheses. And then plus or minus. I see a variable, I put a parentheses, minus 4. Then I'm going to put a parentheses and a parentheses all over 2 times a parentheses. So I'm going to substitute stuff in. So this is going to be negative b, which is going to be a 2. And then 2 squared minus 4 times a, which is 2, and c, which is negative 12. All over 2 times a, which is 2. Sorry for the background noise. So Murga likes to do everything that's in the square root. So I'm going to just do, this is negative 2 plus or minus. And then this is going to be the square root. And I can do 2 squared minus 4 times 2 minus 12 on my calculator. And you're going to get here that it's equal to 100. Now, here in these notes, I got a beautiful square root, because the square root of 100 is technically 10. So this is just 10 right here. Sorry for the background. There's my neighbor. He's leaving for work. So 2 times 2 is 4. And so here this is going to be negative 2 plus or minus. The square root of 100 is 10. This is crazy. Over 4. Now, let me tell you, on your homeworks, you're going to have some real doozies where the square root of this square root is not a beautiful square root. It's maybe the square root of 40. And so let me write that down as an example of what you're going to have to do. If you have a square root of 40, you need to know that this is technically the square root of 4 times 10. And the square root of 4 is beautiful because it's just 2. And the square root of 10 is butt ugly. So you're going to leave it as square root of 10. So this is, you learned this in CCDM 114 and Math 120. This process right here. So just FYI. You need to find perfect squares. Like that 4 is a perfect square because I can take the square root of it. Okay. So here on this one, this is going to be negative 2 plus 10 over 4. And this one's going to be negative 2 minus 10 over 4. So negative 2 plus 10 is going to be 8. And 8 divided by 4 is the 2. And then negative 2 minus 10 is negative 12. Divided by 4 is the negative 3. And there's your 2 answers again. Last little application here. So a baseball is dropped from a stadium seat that is 75 feet above the ground. Its height, s, in feet after t seconds is given by s sub t is equal to 75 minus 16t squared. Estimate to the nearest tenth of a second how long it takes for the baseball to strike the ground. So if the baseball is going to strike the ground, that means that the height is equal to 0. And since the height is going to be s in feet, then if I have s sub t is equal to 75 minus 16t squared, this s sub t is going to be 0. And it's this 0 right here is equal to 75 minus 16t squared. So Murga likes her variables to be positive. So I'm going to add 16t squared to both sides. Keep it in balance. So on the left-hand side, I'm going to be left with 16t squared is equal to 75. Now my t squared, my t is not by itself. It has a 16. It's multiplying. So to get rid of it, I'm going to divide by 16. And so I'm going to be left with, so 16 divided by 16 simplifies to 1. Times t squared is going to give me t squared is equal to 75 over 16. My t is still not by itself. I'm squaring. So to get rid of a squared, I'm going to take the square root. So on the left-hand side, I'm just left with t. And I have to remember that it's going to be positive and negative. Square root of 75 over 16. Now, let's practice our little prerequisite skills here of simplifying stuff. So it's going to be t is equal to positive and negative. So the square root of 75. The square root of 75, it'd be nice for us to know that this is technically, this is the same thing as 25 times 3. And then the square root of 16, well, the square root of 16 is a beautiful 4. So this is going to be t is equal to positive and negative, the square root of 25 times 3, and over the square root of 16. So the square root of 25 is 5, and the square root of 3 is but ugly, so it stays square root of 3. And the square root of 16 is 4, and it's going to be positive and negative. However, so we have 5 square root of 3 over 4 and negative 5 square root of 3 over 4. However, in this real world, we can't go back in time. So this negative answer is unrealistic. And so 5 square root of 3 over 4 is the exact answer. But we want to know approximately how many seconds that is. And if you do that in your calculator, this is going to be t is approximately 2.17 seconds as your answer.